Lesson 8.6, three-dimensional Cartesian coordinate system. In this lesson, we're going to use some ideas we learned in the past, the distance formula and the midpoint formula. We talked about those in 2 dimensions. Now we're going to apply similar ideas to find those same concepts in 3 dimensions. Next, we're going to talk about a way to help you relate the positive axis for the x, y, and z variables. So if you use your right hand and put your 4 fingers so that they're pointing back towards you, your 4 fingers are going to point towards the positive y-axis. Perpendicular from your hand going out is going to represent the positive x-axis, and then your thumb going up represents the positive z-axis. The x, y, and z axes break our coordinate plane up into 8 what's called octants. Okay, lots of times when dealing with application problems, just like we did in 2 dimensionals, a lot of our applications are going to be in the positive axis, just like they were in x and y. So we would be in our positive octant. Now we're going to go through a couple of formulas that should look familiar. First, we're going to go through the distance formula, which is the same as the distance formula we had in 2 dimensions. It's just now we have to find the difference of our third variable z and square that quantity underneath the radical. Similar idea with the midpoint. The only difference is now we have our third variable z, that we have to add those 2 values together and divide by 2. First example, we want to find the distance between the points P1, 2, 3 and Q4, 5, 6, and then find the midpoint of a line segment connecting P to Q. Applying the distance formula, we get d equal to the square root of the difference of our x value squared plus the difference of our y value squared plus the difference of the z values squared. Now we just have to go through, use algebra, and simplify this quantity. So simplifying, we get the square root of 9 plus 9 plus 9, which simplifies to the square root of 27. Using our properties of radical, reduces down to 3 times radical 3. Now we want to find the midpoint of the line segment that connects points P and Q. Applying the formula, we have 1 plus 4 divided by 2, 2 plus 5 divided by 2, and 3 plus 6 divided by 2. Simplifying each of those fractions, our ordered triple for the midpoint turns into 5 halves, 7 halves, and 9 halves. The last thing we need to talk about in this lesson is the standard equation of a sphere. In 2 dimensions, we talked about the equation of a circle. Now that we're in 3 dimensions, we're going to be dealing with the equation of a sphere. So if we have the center of our sphere at the ordered triple HKL and we have the radius r, this is our basic equation. X minus h quantity squared plus y minus k quantity squared plus z minus l quantity squared is equal to r squared. The last example, we want to find the standard equation of a sphere with the center at the ordered triple 1, 2, 3 and a radius of 4. So all we have to do is plug these values for h, k, and l and r into the formula. Thus, the equation for this sphere ends up being x minus 1 squared plus y minus 2 squared plus z minus 3 squared equal to 4 squared. So in this lesson, just reviewed some ideas we talked about in 2 dimensions, dealing with the distance formula and the midpoint formula, and then finally the standard equation of a sphere, just dealing with these concepts in 3 dimensions.